Welcome back. This is video 3, part 2 of making schematics and PCBs with KiCad. This part is continuing our capturing a schematic in KiCad, specifically the electrical rules check step. So here's our schematic that we created. The layout's good. We like where everything's at. We've done our annotation, so each symbol is annotated with a number and a value. Now we're ready to check to see if there's any problems, if everything's connected correctly to each other. Up at the top, hover over this little bug, and also it says perform electrical rules check. So we click on that bug, and it will tell us if there's any problems. I'll click on that, and if there are any problems, it will come up with an error list. So I'm going to click run, and it tells me it's got 3 errors. A pin is connected to other pins but not driven by any pin. What that means is that in KiCad it has to be specified where power is connected. So it shows pin 1 is supposed to be a power input for the 555 IC, but it doesn't have a power input. It doesn't know where that's coming from. It also has a pin that is not connected to anything else. Right? That's pin 5 on the IC. Has no connection, so we either need to specify it has no connection or connect it to something. And pin 8, a power input, is not driven. So what we want to do is close that for now and take care of those problems. So pin 1, pin 8, and pin 5. It flags with these little green arrows where our problems are. So I want to clarify where power is coming from. For KiCad, everything needs to be specified where power is coming from. That's called placing a power flag. It's not a real component, it's just a way for KiCad to tell where power is coming and going. Now for the battery, I'm going to specify the value of the battery. In the original schematic it doesn't specify that, but when I breadboarded it out, I used a 9-volt battery and everything worked great. So I'm going to set that level as a 9-volt. So if I double click on my battery symbol, my reference is BT1, but my value, I'll change that to 9 volts. Well, I can see that, but the computer can't really tell that that's actually where power is coming from. So I have to set a power flag. So if I run my electrical rules check at this point, it comes up with some errors. Pin 1 of my IC is not connected to any power line. Neither is pin 5. There's no connection there, and pin 8, where power is supposed to be input into the IC, there's no power, or there's no specification that there's power. So that's why I need to set my power flags. So my 4th icon down, it says place a power port. So I'm going to click on that, and I want to add a power port to the battery connection. So I'm going to click here, and it'll come up with a filter. I can search for power flag. There it is, power flag right there. It's a special symbol telling the electrical rules check where power comes from. So I'm going to say yes, okay. I want to attach it to my battery, but see how it's kind of on top of the line. So again, I can hit the hotkey R to rotate that until I get it the way I want, connect it to my battery. I can also attach it to pin 8. So it says, yes, I know I'm getting power to pin 8 and another one at pin 1. Again, I'm going to rotate that. And then pin 5 is no connection. Now, I could leave it as no connection, and when I breadboarded it up, it worked fine. I usually don't like those no connection pins. That's called a floating pin. But I'll show you how to do a no connection. On the right-hand menu bar, there's a little X here. It says place a no connection flag. So if I click on that, go over to pin 5, click there, that will tell my electrical rules check that there should not be a connection to that pin. So now I can do my electrical rules check again. If the errors are not deleted, you can delete those and then rerun it. I'm going to rerun that, and it says it's finished, no errors, so I know everything is going to work for this schematic in KiCad the way it should. Now the next step in KiCad is to assign PCB footprints. See, this is the symbols, but real components have a physical size and shape, and I need to specify to the program what the size and shape of each component is and where it should be placed relative to all the other components. so the program will know how to produce the board, the printed circuit board. So that will be the subject of the next video in this series. Thank you, and I hope you learned a lot. Go forth and practice.